other differential equation, we can use the separable techniques to solve it, or we can also use the linear differential equations. All depends on the format it takes. Okay, as I'm coming in, just begin to say I would like to start from the second question, number two. Question two, solve the differential equation. Your dy dx is equal to what? Dy dx is equal to 6xy squared. And then we have the boundary condition with y equal to 1 and x equal to 2, giving the answer in the form of y equal to f of x. Y equal to f of x. Okay, for question 2, you can realize, let's quickly have a recap on separable differential equation. How does it look like? Okay, the form is this: dy dx will be equal to product of two functions, f of x and g of y. You could take this form, or you could also take dy dx equal to f of x times 1 over g of y. So if you take the two form, so to contain two different functions, x and y, okay, and then you separate the what? The dependent variable on one side and independent variable on the other side, okay. The dependent variable is y, while the independent is x. So what we are going to do, let's take this form, is to remove this dy, this g of y from here. Remove it from here. That means you're going to multiply both sides by what? By g of y dy. At the same time, also remove the x from here, and that will give you f of x, the x. The next step is to integrate both sides of the equation. Okay? And if you do that, we can assume that this is what? G of y equal to what? Equal to. This one also, if you integrate that, let's make it capital F of x plus what? Plus c. Okay? So if you're having of this form also, you just have to divide both sides by g of y, so that g of y can leave this place and come here. And this one also multiply both sides by the x. Okay, so that's that on the separable differential equation. Each of them has their form, so you need to check the format of the question. Does it conform to the standard rules? Does it conform to the format? Then if it conforms to the format, then you solve it in a separable differential way. Okay, so let's see solution to the first question. We have the y, the x equal to what? Equal to 6xy squared. Okay, so this one is f of x. This one is what? Is g of y. Okay, follow the formats, follow the techniques, remove the g of y from here, remove y squared from here. That will be 1 over y squared, the y, equal to what? 6x. Remove this one from here also by multiplying both sides by dx. So we have this. Then introduce your integral sign to both sides of the equation. Okay, and with this one, there's no direct table, but we can do the algebra. That will be y to the power minus 2. Remove this 1 over, which is the minus y, equal to integral of 6x dx. Okay, and the general format for integration, integral of x to the power n will give you the power plus 1 over n plus 1 plus c. So that's how to integrate the power plus 1, that y minus 1 equal to this one. The power here is 1, that will be 6x. 1 plus 1, that's 2 over 2 plus what? Plus c, the constant of integration, and that will be equal to y minus 1 equal to what? 3x squared plus c, which is the same as what 1 over y equal to 3x squared plus c. Then we can reciprocate both sides, and that will be y equal to what 1 over what 3x squared plus c. As you are coming in, just begin to say I. As you are coming in, just begin to say I. Just begin to say I. If you are yet to subscribe, do so right now. If you are yet to subscribe, do so right now. As you are coming in, just begin to say I. As you are coming in, just begin to say I. As we are coming in, just begin to say I. Plus y plus y. And then we are told that x is not equal to 0, y is also not equal to 0. So what we do here, we can factorize y is there. So we can factorize that. That will be x plus 1. We can do that. Okay? And then remove this x squared from here. So I have to follow the standard form. That will equal to what? The y, the x is equal to y. And if you are removing this one from here, also remove the y from here. So that will be 1 over y equal to what? Equal to x plus 1 over what? Over x squared. Okay? And then finally, remove this the x from here. So we have 1 over y dy equal to what? Equal to x over x squared plus 1 over x squared dx. Okay? So in the algebra, this will be this one over this one, and then this one over this one. Okay? So that's what we have in that place. We have separated the variable. Then the next thing to do is to introduce our integral sign. Okay? And don't forget from the table, on the integral table, 1 over x dx, okay, give you natural logarithm of the function. So this one will be what? Natural logarithm of the function y equal to this one. If you divide this one, that will be 1 over x also. This is 1 over x. Let's put that one there. That's 1 over x. Okay, dx. And then plus. This one will be what? Integral of x to the power minus 2 dx. Okay? So we're going to have natural logarithm of the function y equal to this one also. That will be natural logarithm of the function x. Okay? And this one will be what? The power plus 1. Okay? That will be plus x power minus 1 over what? Over minus 1 plus c. Plus c. So that's what we have there. Begin to type your question, your comments. Okay? As you are coming in, just begin to say I. As you are coming in, just begin to say I. Okay? Then plus minus. That will give us a minus. So we have natural logarithm of x minus r. This one is what? Minus 1. That will be 1 over what? 1 over x plus c. Okay? And this is what? So that's what we have there. And we are told to give our answer in form of y equal to what? F of x. Y equal to f of x. So in that case now, this one, natural logarithm, is equal to the logarithm to base e of the function. Okay? Logarithm to base e of the function. So that's the meaning of natural logarithm. Okay? That's the meaning of natural logarithm. And we can now have this is equal to y equal to e to power everything we have there, 1 over x plus c. Okay? 1 over x plus c. So we have converted from exponential to what? To logarithm form. Okay? Don't forget, when you have logarithm to base e, the function equal to whatever equal to, okay, it's going to be the function y equal to, this one will come on top of this, and that will be e to power x. And that's what we have done in that case, e to power everything we have here. Okay? that's what we have there. That's what we have there. You just need to begin to do the work in these places. Okay. This one implies e to power natural logarithm of x, okay, times e to power minus 1 over x, okay, and then times e to power c, okay. So that's what we have. This one, e to power natural logarithm of x, give us what? Give us this. The natural, whenever you have e function to the exponent of natural logarithm, okay, it's going to give you that function. Note, e to power natural logarithm of f of x will give you f of x. Okay, so that one will give us what? That one will give us x, e to power what? Minus 1 over x. Okay, this constant, this e to power constant, we can just give it a variable because it's a constant. Call this one, call it a, or call it b, whatever you like, and just give it a constant value. Okay, so that is the y equal to what? Equal to this one. So that's that on that case. That's that on that case. So y equal to what? E to power what? E to power this one is what? Is x, and then e to power minus 1 over x, and this one is b, this one is b. Okay, so you realize that your dy dx, you're going to find the differential equation or solve the differential equation. You realize that your the y dx is having two functions, x times x, that's f of x. This is f of x, and then we have this one, cos square y. This is g of y. Okay, so we're going to use what? Separate what? Separate the variable. Okay, separate the variable. Okay, by removing this one from here, and that will be equal to what? 1 over what? 1 over cos square y, dy. And at the same time, remove this one from here, and that will be equal to what? X sine 2x. Okay, x. And after that, introduce your what? Your integral sign to both sides. Okay, separate the variable. Okay, and then 1 over cos square x. 1 over cos square x, notes the inverse 1 over cos is sec x. So this will be equal to sec square y dy. Okay, that's a sec square y. That's 1 over cos square y, and this one is what? X sine 2x dx. Okay, so that's that on that case, and we integrate sec square y. We're going to have tan y. Okay, we're going to have tan y equal to what? We integrate sec square y. It's going to give us arctan sec square y. That's our tan y. If we integrate sec square y, that's our tan y equal to what? It's equal to this. Okay, and this one is a product. We have the first one, x times sine 2x, x times sine x times sine 2x. That call for integration by parts. Integration by parts, because it's a product of two items. Let's my view, let it be this. Okay, and the v, let it be sine 2x. Okay, so this one, the u is equal to the x, and then integrate this one, okay, and that will be equal to what? V equal to what? Minus cos 2x. If you integrate sine 2x, okay, if you go over sine is minus cosine of the function, and then you divide by derivative of the composite function. That's a 2. Okay, so we're going to have, so the figure of this one will be equal to what? uv minus v, figure of v is u. So that's the formula for that. Okay, so let's begin to input the u and v. My u is x, my v is what? Is minus cos 2x over 2, and then minus integral of v. My v is what? Minus cos 2x over 2, and then the u. My du is what? Yes. Okay, and that will give me minus half x cos 2x. Okay, minus times minus, that's a plus. And then I can take the half outside the integral, and that will be integral of cosine. Integral of cosine is what? Is sine 2x. Okay, and then you divide by derivative of the composite function over what? Over 2. Okay, so that's that on the right hand side. So final conclusion, we're having tan y equal to what? Put your answer for question 1. Let's see what you get for question 1. Question one. Okay, let's see what you get for question 1. I want the answer in the comment section for number 1. Then for question 2, let's see solution for 2. Y prime is the same thing as y dx. Okay, and that will be equal to the y dx. Move this one to the other side, and that will be x squared plus x. Okay, so that's what we have in that place. Then we can factorize the x one, x squared. You can take it out, and that will be 1 plus y squared. Okay, and then separate the variable by dividing both sides by 1 plus y squared. That's 1 over 1 plus y squared. The y. Remove this one from here, and that's what x squared dx. And then introduce your integral sign. Over 1 plus y squared. Okay, it's going to give you arctan y. It's a table. It's an integral table. Integral of 1 over 1 plus y squared is going to give you arctan y. It's a direct table. Okay. So on the left, on this side, on the left side, we're going to have arctan y equal to. If you integrate this one, that will be the power plus 1 over 3 plus c. Okay, that's the answer. Okay, but if you want to, let's try to solve it in this form, which will be equal to, we're going to take the tan of both sides. If you take tan, tangents of an inverse function, tan of arctan, it's going to give you y equal to what? Tan x cubed over 3 plus what? Plus c. So we want to see the general format for linear differential equation. How does it look like? What is the form of linear first order differential equation? Okay, we've done the separable first order differential equation. So we want to see linear first order differential equation. The format is y dx plus p of x y equal to what? It could be f of x, it could be q of x. So that's the form. That's how it looks like. Because each of these differential equations have their form. Okay, the separable, okay, has its own form. The linear also has its own form. Linear first order differential equation has its own form, its own format, and this is the format. Okay, And what are the things to do? The next question is, for this form, how do we get a general solution? What are the steps, okay, to be taken to get the general solution for linear first order differential equation? Okay, the general solution for linear is y equal to 1 over integral function, 1 over integral, 1 over integrating factor, okay, open brackets, the integral, the integrating factor, times f of x. Don't forget the integral sign here, dx, plus what? Plus c. Okay? Where this is called is equal to e to the power p of x dx. Okay? We call this one integrating factor. We call it integrating factor, and that's equal to p of x dx. Okay, so that's that on this case on linear differential equation, linear first order differential equation. So what we need now is the application. How do we apply it? Okay, how do we use all these things? How do we solve questions? Okay, integrating factor. This is an integrating factor. That's an integrating factor. So let's go to our question. If you look at our question, solve the differential equation, y dx is equal to what? X minus 2xy. Okay? What do? We're going to write this one in the standard form. Okay? And that will be equal to the y solution. That will be the y dx. Okay? Move this one to the other side. That will be 2xy equals to what? If you move the minus 2xy, that will be plus. That's a plus, and that's a this. So we can see now we have our y dx, we have our p of x. Our p of x in this case is 2x. Okay? Where p of x is what? Is 2x. Okay? And f of x is what? And f of x is x. So that's what we have in that case. So coming in, just begin to say hi. Begin to share the links of this video across your different platforms. They're just coming for the first time. Subscribe, like, and share. Subscribe, like, and share. The integral factor is equal to what? E to power integral p of x dx, and that will be equal to e. My p of x is what? Is 2x. Okay, my p of x is 2x. Okay, so that's what we have in that place. And then the integral factor will be equal to what? Will be equal to e 2x over 2. Okay, when you have an e function, the integral is what? It's the same function, but you have to divide by the derivative of the power. And that's what we have done for that case. So the integral factor as a function of x is this. Okay, then we can now write the general solution. The general solution will be what? 1 over integral factor, which is e2x over 2. Open your brackets. That will be this one. Integral factor is what? Is e2x, e to the power 2x over 2 times f of x. My f of x is what? Is this dx, and then plus c. Don't forget your integral sign, and then close the brackets. And y will be equal to 2 over e to the power 2x. Then integral sign, that will be what? These two, we can take it out, the integrations. We can take the two outside the integral sign, and that will be this e2x dx plus c. Okay, and this one, you can take it out. This is product, under the integration, and then we can apply integration by parts, and this will be equal to my u is this, my v is this, okay? So the u is equal to dx, and then integrate this, so v is equal to e2x over 2, okay? So the question is that how do we, this is just integration by parts, and that's another topic on its own. So we're going to have now uv minus integral of v u. U is what? Is this. V is this one. That's my v minus integral of v. That's e2x. I can take these two outside. That's 1 over 2. Okay. The u is the x. Okay. And then I'm having now this one minus 1 over 2. If you integrate e to power 2x, that will be e2x over what? Over 2 plus 1 plus c. Okay? Now, I'm going to have y equal to 2 over e to the power 2x, open your brackets. 1 over 2 is outside. This 1 over 2 here, 2 cancel here, that's 1. So this one is still 1 over 2. This one is 1. We have 1 there. And then for the integral of integration by parts, we're having half times x e to the power 2x, okay, minus 1 over 4 e to the power 2x plus c. And that's the general solution for the question. Another thing we can do now is to allow this one, the integral factor, to come in. If we like, we can do so, or we leave it in that form. So if it goes in, so this one and this one we cancel. We have 1 over 2 x, okay, minus 1 over 4. This one and this one will be cancel. 1 over 4, and then plus c over c plus c e to the power what? Minus 2x. So that's that. In that case, you can do it this way, and this, and then you have that. So that's that on these. You don't want to be able to confuse, cause a confusion. We have the question, solve the differential equation. T dx dx dt plus what? 2x equal to t squared minus t plus 1. So let's have a quick review of the form for linear differential equation. We said the format is this plus what? P of x y equal to what? F of x. So if you check very well, the function you have here is the same function here. Okay? The function you have here is the one here. And likewise, the function here is one here. So we're going to use that to solve this one. Then step 1. The step 1 is to divide each of the parts of the equation by this t. The t must leave this place to conform to this format. And that will be equal to what? The t plus t over t x, and then equal to t squared over t, that's a t, minus t over t, that's 1, and then plus 1 over t, that's a 1 over t, so we have this. Okay, so that's what we have in that case. Okay, so that's what we have in that case. So it now implies that this is a function of t. This equation is a function of t. Then we need to get your p of t. P of t. Here, p of what? P of x. So you get your p of t. This is what? 2 over what? Over t. Then you get the integral factor, the integrating factor. Get the integrating factor, and that will be equal to what? That will be equal to e integral 2 over t. T. Take these two outside. That will be 2 1 over t t. And that, if you integrate this one, the exponent, you're going to have e 2 times natural logarithm of what? Of t. Okay? And that will be equal to e natural logarithm t squared. These two will come here. Okay? And that will give us what? T squared as the integrating factor. Okay? Don't forget when we said that e to power of natural logarithm of a function that is going to give us that the function. That's what we have applied in that place. As we are coming in, just begin to say begin to share the links across your different platform. Share the links across your different platform. So we've gotten our what? Integrating factor. Then we can get the general solution. We can get the general solution, which is y equal to the formula is 1 over integrating factor. Okay, open your brackets. Integrating factor. Okay, and functions of t, and then times f of t. Okay, the t plus c. So that's the formula for the general solution. As you're coming in, just begin to say you're just coming for the first time, you're yet to subscribe, please do so right now. Begin to share the links across your different platforms. Share, share, share. Like, subscribe, share. Like, share, and subscribe. So we're going to have y equal to 1 over t squared. Okay. Don't forget your integral sign here. Integral sign. Okay. That's the integrating factor is t squared. F of t is t minus 1 plus 1 over t, t, and then plus c. Okay. Then we have 1 over t squared. Okay. Can we open the brackets? This one times this one, that's a t cube. This one times this one minus t squared, and then plus t. Okay, c. Okay, and then plus c. Close the brackets, and then begin to integrate each of this, and that will be 1 over t squared. Open your brackets. Integral over t cube, that will be the power plus 1. That's a 4 over 4 plus. This is a t squared. The 2 plus 1, that's a t cube over 3 plus this one is having power 1, that's a t squared over 2. Then close the brackets, and then plus what? Plus c. So that's the y. Okay, and that is the answer. So if you like, you can allow these brackets to come in